Today's video will demonstrate how to refactor a program into the separation of concerns. Hello, I'm James Helfrich. Separation of concerns seems easy in concept. We separate a program or a part of a program into the interface, the business logic, and the storage. But the question is, how do we actually do that for a real program? Well, this video will demonstrate that process with a game of chess. Okay, let's take a look at our original design for the game of chess. We're going to have a board class, which is going to contain a collection of public methods, which we're not going to really worry about right now. And then we're going to have a piece class. Now, this piece is going to know its position on the chessboard, the last time it moved, the number of moves it has, and what color it is, namely whether it's black or white. And of course, I'm going to have a collection of public methods. I want to know the type of piece. Is it a bishop, a rook, a pawn? I want to be able to display the piece, get the number of possible moves. I want to know if I'm white, and I want to be able to update its position. Now, of course, the board is going to have several different pieces, so that's going to be by aggregation. But since the board is going to create and destroy the pieces, we're going to use the composition form of aggregation. So we use the filled diamond, and there's going to be exactly 64, which means the board class must needs have a 64 piece array. All right, so the piece is going to have a position class by composition. It's also going to return a piece type, so it's not going to have a piece type, it just return one, and it's also going to return a move, well, a collection of move. Now, observe that the piece class has three pure virtual functions: get type, display, and get moves. And so therefore I must have, well, a rook by inheritance, and a knight, and a bishop, and a pawn, and a space, and a couple other ones as well. Okay, each one of these must implement get type, display, as well as get moves. Okay, so this is my traditional and straightforward implementation. Observe that the piece class and its derived classes both have a public interface for board, contains the logic, namely get possible moves, as well as his attributes, namely position, last move, num moves, and is white. Now, what we'd like to do is separate this into the three concerns. Okay, so my first step of the storage concern is to create a piece storage. Now I'm going to have a position, a last move, num moves, and is white, all as private member variables. I'm also going to have a get position and a set position. I'm going to have a set moved, get last move, and get num moves, and I'm going to have an is white. Now, right now, this class is completely independent of piece. Piece is not modified itself in any capacity, so I can always add a class and not impact the rest of the program. But now I want to have piece and piece storage be connected, and this connection is going to be composition, and there's going to be exactly one of these. And when I do this, then I can remove the position, last move, num moves, and is white from piece, and I can replace it with a piece storage. Okay, let's see how that works. Okay, so here's the code to my chess game. I want to make sure it works. I'm going to compile it and build succeeded. Good, so everything works fine. Now, initially, I'm going to go into my piece class, and right now I have my num moves, last move is white and position, and I want to turn this into its own piece storage. So I'm going to do that initially.
First, I'm going to create my piece storage class, and I'm going to take the attributes directly from the piece and paste them in. Now I'm going to make my public getters and setters, first for position, and then for the history of how this piece is moved. Now, notice that I'm not doing any validation here. I'm not doing anything complex. Anything complex is going to happen in the business logic. These are just getters and setters. And of course, I need my constructor as well, so I can set my isWhite attribute. Okay, I'm done.
Okay, so now I've implemented my piece storage class. I'm going to build it to make sure it works, and my build succeeded. Now observe, I haven't hooked anything up. I want to do things in the smallest bite-sized chunks I can. I just simply brought in the four attributes from piece, and then I use my getters and setters, so this is completely straightforward. Okay, the next step I want to do is to hook piece storage up into the piece class.
So I'm going to create an attribute called piece storage, and then in my constructors, I'm going to initialize that attribute, and then I should be good to go. Very simple.
Okay, now I've created my attribute, piece storage. I'm going to build to make sure nothing broke and everything's succeeded. All right, we're doing good. Now what I'd like to do is get rid of these guys, which means now I have to refer to piece storage rather than num moves, last move, F white, and position.
Now, the real challenge here is to find all instances of piece dot those four attributes. And I have to look for each one of them and change the location from piece dot to piece dot storage dot, that same attribute name. And fortunately, the on-demand compiling is going to help me find these errors super quickly, but I'm probably going to make a mistake or two as I go through. So I absolutely want to make sure that I compile immediately after finishing this, because those are going to be the errors that are easy to find. The sooner that I find the error, then the easier will be to fix the error.
Okay, I think I have everything hooked up. I'm going to try to build, see if I made a mistake. Build succeeded. Okay, now for the moment of truth, I'm going to remove the old attributes. Build again, and build failed. Looks like I missed a few.
Okay, so now I'm going to find, oh, there's another one, and then there's another one. In each one of these cases, all I have to do is add that extra level of indirection from the direct access of the attribute to I have to go through piece storage to get the attribute. And it's a bit tedious here, but fortunately, all the changes look the same, so it's just a copy paste.
Okay, looks like I got it all working. All right, let's go to the next step. Now that I've finished separating the storage concern, the next step is to separate the business logic concern. The business logic for the piece is how it moves. And so notice in my piece class, I have my get moves, and then I have my helper functions get moves slide and get moves no slide. What I want to do is move these to a business logic concern. The first step, I'm going to create a piece logic class all by itself, and I can add this, of course, without any problems. Then I want to have a pointer to storage. So I'm going to have a storage, and this can be by composition, it would be exactly one. Now observe, piece is still going to have to access the storage information, even though it's no longer going to be directly connected to it, which means piece logic has to provide a get position, update position, is white, get last move, get number of moves that was previously accessed from storage. And then I'm going to have my piece logic is going to be a member variable of piece. So I'm going to have an association between piece and piece logic. This association is going to be composition and to be exactly one, which means I can get rid of my old connection to piece storage. So let's write the code up to this point in time and then we'll continue on. Okay, the first thing I'm going to do is I'm going to create a piece logic.
Okay, so my piece logic class is going to be implemented immediately under the piece storage class, and it's going to have a piece storage by composition. I'm going to create my usual constructors and an assignment operator and things like that. And now I'm just going to copy all of the getters and setters I have from piece storage because the interface is going to have to pass through logic to get to storage.
Okay, so only thing I've done at this point in time is I've created a piece business logic class. It's going to have a piece storage as an attribute, and it's just going to pass through all the requests from the interface onto the storage at this point in time. In other words, I do nothing. Now, this is not hooked up to the rest of the program, so I should be able to build, and I expect no problems. Okay, now what I want to do is have the interface talk to the business logic rather than storage, and I'm going to make that change now.
Now, since logic has the same interface as storage, I just have to change all the references from talking to storage directly to now talking to logic directly.
Okay, I think I made the changes. I'm going to build it now. And I failed. Looks like I missed a few pieces here. All right, now my build succeeded. Okay, so now basically all I've done is I made an intermediate class called Business Logic, which passes through all the requests from piece interface on the piece storage, but I haven't really done anything yet. The next step is to get the business logic into the piece logic from the piece class. And this involves moving get moves slide, and get moves no slide. So the first thing I'm going to do is I'm going to create a get moves pure virtual function. And once I create a pure virtual function, I need to create a derived class. And I'm going to call this bishop logic. And this is going to be related by inheritance. And I'm going to get a king logic and a bunch of other ones as well. Now, in order for me to implement these, I got to get my get move slide and get moves no slide and move them from piece on over. And then I'm going to remove my get moves from the knight and from the pawn and from all the other ones, as well as the pure virtual function from piece. And it's no longer going to be a pure virtual function. It's going to be a normal function. And it's going to pass that request onto piece logic, which we'll call it get moves class. And now all the business logic associated with a piece will be in piece logic. It will no longer be in piece. Let's make that change now.
Okay, first of all, I'm going to add my get moves per virtual functions to my logic, and then I'm going to make all my derived classes for the various types of business logic, namely my pawn business logic, my knight business logic, and my bishop business logic, and so on. And each one of these will have the get moves virtual function. That the pure virtual function was defined in the derived class, in the base class. I'm also going to have to make sure that whenever someone talks to the get moves, it's going to talk to the business logic version. That's what I'm doing right now. Okay, now here's a trick here. Because my logic is going to be polymorphic, I have to make sure that that's a pointer to a business logic, not a business logic instance itself, which means I have to change all my business logic to a pointer to business logic. I have to allocate it with new and delete it with delete. And I also have to change all my dots to arrows, and that's quite tedious. And that's basically what this change I'm doing right here. I also made a little mistake in that I had my my pure virtual function be a constant method, but then I had my derived class that were not constant, so I had to make that change right here. And I also have to make sure I have a constructor for each version of my derived business logic so that when I allocate it, then I can allocate it correctly. And of course, each one needs to be public rather than private, otherwise I won't be able to access it or compile it. Okay, the next compiler error I made is that I forgot to allocate the business logic for pawn from the pawn constructor, and I have to make sure that everything is set up correctly so that happens. I have to do that also for the other 5 piece types. And of course, I have to do the same thing for the space, even though the space's get moves is going to return an empty set. Each one of these changes is kind of tedious. Now it's interesting because I went through, now that all the logic to get the moves for a piece is now in the logic, I no longer have to say business logic dot get position, business logic dot that. I can remove all those intermediate steps, and so the code is actually far more elegant.
Okay, so now I created my business logic, my king logic, and all the others. The next step, of course, is to move the get moves no slide and get moves slide from the knight, the pawn, all the way to the knight logic, business logic. I'm going to do that and move next.
Okay, I'm going to grab the get possible moves slide and no slide from my piece base class. I'm going to drop it into piece logic base class. Then I'm going to add my get moves to the business logic as well as to each of the derived classes. And initially, I'm just going to create them as empty classes because empty methods because I'm just going to have placeholders now. Now, in doing so, I have to change the class association for the get moves from, let's say, pawn to business logic pawn. And that's going to simplify the way that I call each of the methods. And that's a bit tedious, a bunch of search and replace. The code is really easy to write, but there's a whole bunch of instances. And once again, when I find those compiler errors, then it makes it really easy for me to find them.
Okay, so now we've successfully moved all of the business logic to the piece logic and its derived classes. Now the base class and the knight, pawn, rook, bishop, and so on derived classes, these are only interface classes. They only display and they only pass on the requests to the logic. The logic will handle all the business logic, namely the rules of the game. And then storage will handle all the storage. Notice there's not a single attribute in my interface or my business logic except for the pointer to the logic and the storage. So now we've successfully done separation of concerns. Now, one final thought here. Notice how I have a get type in my interface, but I don't have anything similar in my storage. The reason for that is because I know which type I am based on my derived class. If I wanted to have a more pure implementation, I would have had another attribute in my piece storage, which says my type, and then just pass it on through. Or what I did instead is my get type just returns I'm a knight, and my pawn get type just returns I'm a pawn, and so on. So it makes it a lot more simple. We can learn more about separation of concerns in the separation of concerns chapter of the software design textbook.